Hi there, Year 12. Here we are again. Who would have thought? We're going to push on. It is really important that those of you in 12B, so that's Pat and James and gang, that you watch the end of the partial fractions 2 video, because I just got a little bit further with the other group, and I've linked that in the email with the time stamp as part of the link. So it's really important that you watch that, because that sets us up for today's lesson, because we get into, well, it's a reminder of long division of polynomials, long division of algebra. So make sure, if you haven't done that already, stop this video and go and watch that one, and then come back to this one. Right, so yeah, in that lesson, so in 12E, Jacob and co, you were here when we actually did sums like this, and we did it by doing long division, that divided by that. This was our answer, and the remainder was d, so it was d out of the divisor, x minus 3. And we did a couple of those, and we found that the remainder is always has an order of 1 less than the divisor. So here the divisor has an order of 1, so we're expecting the remainder just to be a number, order 0. Now, what we didn't do was address questions like this, which looks very similar to this. So you might be asked to find the values of a, b, c, and d in this expression. And I'm hoping you can see that actually this is the same question. All that we've done going from here to here is we've divided everything by x minus 3. So in order to answer this question, I would still do my polynomial long division. I'd have that underneath my bracket, remembering that I need a dummy x value because there's no x there. And that is going to be the thing I'm dividing by. My answer will be this, and the remainder will be that. So my point is that these two are two ways of asking exactly the same question. So for those of you with the textbook, and you should all have a copy of the textbook, because I think I've emailed everyone the PDF now, including some of you several times. But anyway, yeah, so page 16, question 5, we've got a question that looks like this. So it's in this form. So the first thing I'm going to do is make it look like this. So I'm going to divide everything by 2x squared minus 2. Not something as simple as x minus 3, a bit more complicated, but here we go. So I'm going to divide everything by 2x squared plus 2. So that's just left with ax plus b. Can put a bracket there, don't really need it. And this, I'm going to treat this as one thing that I divide by 2x squared plus 2. So it becomes so this pair here is just like this pair here. Going from here to here, you're just dividing everything by x minus 3. Going from here to here, you're dividing everything by 2x squared plus 2. So to solve it, I'm going to do long division. I'm going to set out my long division like this. This is the thing I am dividing. Again, no x term, so I need a dummy x term. And I'm dividing by this, more complicated, it's a quadratic, but again, I need to remember that I need a dummy x term. So go on, pause the video and have a go at doing that division. Your first question is going to be, what do I multiply that by to make that? Because I'm dividing by a quadratic order 2, I know my remainder is going to be order 1. Pause and have a go. Actually, although the ones where you're dividing by something bigger, quadratic in this case, they look a bit scary, actually they're quicker. So to turn that into that, I needed to multiply by 4x, so I multiplied 4x by 2x squared, 4x by 0x, and 4x times 2. And so now I'm going to do this, take away this to work out what's left. 2 take away 0 is 2x squared, and 0 take away 8 is minus 8x. And I'm going to bring down the 5, 3 terms in the thing I'm dividing by, the divisor, so I need 3 terms here. What do I do to this to turn it into this? I have to do nothing. Well, rather, I have to multiply it by 1. So 1 times 2x squared, 1 times 0x, and 1 times 2. And then subtraction, so that take away that is nothing. Minus 8 take away nothing. 5 take away 2. So what does that mean in terms of the answer? Well, it means that this is 4x plus 1. That's my answer. We call that the quotient. That's the quotient. And the remainder is this. And referring back to the original question, if I want to write it in this form, well, okay, so ax plus b is 4x plus 1. That's going to stay the same, obviously. And that's going to be minus 8x plus 3. So both questions, if it was asked like this or asked like this, can be solved by a long multiplication. So go on, while we've got that page open in the textbook, it's actually on the facing page, have a go at page 17 and question 9. That again is written in this form here, but I would turn it into that form there first. Pause and come back when you've had a go at that one. Okay, so here's the question as it was presented to me. I started by dividing everything by x squared minus 3, which is the only thing on this side which hasn't got missing letters, so that's how I knew it was what I needed to divide by. So it becomes that, that, and that. So this sum here I didn't need any dummy values here, but I did need a dummy x in my divisor. So it all trickled through and gave me that as my remainder. So in terms of the original question, so this is my ax squared plus bx plus c. So a is 3, b is minus 4, and c is 1. And then this is my remainder, here or here. So d is 4, and e is 1. And in questions like this one, where it just says find the values of A, B, C, D, and E, you don't actually need to sort of rewrite it at the end. You can just say A equals 3, B is minus 4, C is 1, D is 4, and E is 1. Okay, so we've looked at two sorts of sum. Sums presented like this, sums presented like this, both of which can be solved using long division. But there is another way we can solve these sorts of questions. So let's just do one more using division. It's a bit like it's in one given to us in this form. So on page 16, just have a go at question 4. Make sure you need a dummy value in your divisor, in the number you're dividing by, and do division for that one. And I'll do it as well, and then we'll come back and look at the alternative way that we can answer that question. Pause and have a go. Okay, so it's quite an odd one, this, isn't it? Because the dividend and the divisor, these both have the same order, our quotient, our answer, is actually just a number. No algebra involved at all. But as always, the remainder will have an order of 1 less than the divisor, so quadratic, order 2, order 1. So we get this. So I now know that m is 2, and n is 4, and p is 7. And just remember, it's always a bit tricky here, isn't it? 5 minus minus 2, 5 plus 2 is 7. Okay, so we could get this answer a different way. So if you're happy with the division, fine, don't worry about it. But, you know, I like to equip you with as many different ways as possible. So if we go back to this original question, and we do the reverse. So remember I said get from here to here by dividing everything by x minus 3. Well, I'm going to do the reverse here. I'm going to multiply everything by x squared minus 1. So that means this becomes this will become m times 2x minus 1, and this will become just nx plus p. Multiplying by 2x minus 1 will kill the fraction, so you're left with that. I'm then going to expand this, quite an easy one to expand. And now I'm going to use equating. Equating was the method that we used, we talked about at the start of partial fractions as an alternative to substitution. So if I look at this expression, this thing here says that this side will have to equal this side. So let's compare the x squareds. I've got 2 of them here and m of them here. So I straight away now know that that m is 2. I know there's an m here, but that's not an x squared, is it? All I'm doing is comparing the x squareds. Let's do the same with the x's. I've got 4 x's here, and I've got n x's here. So I now know that n is 4. And then lastly, let's just look at the numbers. So looking at the constant terms, I've got 5 on this side. And I've got, well, this doesn't have any algebra, so I've got a minus m, and I've got a plus p. Those are the terms that don't involve algebra, x's in this case. But hang on a minute, I know what m is. M is 2, so minus m will be minus 2. So p is equal to 7. M is 2, n is 4, p is 7, which of course is what we'd already got using the alternative method. So equating sometimes is a little bit easier. Sometimes it's a bit harder, sometimes it's a bit easier. So have a go at page 16, question 5. Question 5 is one where it's already written in this form. So it's already written in this form. And that tends to lend itself towards equating because you think, well, I'm going to multiply that out. Remember, this is only an alternative to dividing, so you've still got the option of doing this and doing a long division. The same is true of page 16, question 5. You could use the long division method, but yeah, have a go at using question 5. And then just one more from that exercise. Have a look at question 6, and I'll let you choose whether you do the division or whether you use the equating. See if you can get an answer to that one. So I'm going to stop the video at that point and just come back with a solution to these two, and that will be the end of our work for today. So yeah, pause and have a go at those two. Okay, so here's number 5. So I could have just done that divided by 2x squared plus 0x plus 2, done it the division way, but I've chosen to do this one the equating way. So I just had to multiply out that bracket. Don't forget the cx plus d is there. And then I just compare them. I had no idea why I did x before x squared, doesn't matter. But anyway, I got my value. So I got a was 4, b was 1, c was minus 8, and d was 3. Could have done it by dividing, chose to do it by equating. Question 6, I did both. So I've started by doing it by dividing. So question 6 asked me to do this divided by this. That's my quotient, my answer, that's my remainder. So those are the numbers that I get for A, B, C and D. I could, however, have done it using equating. And so to do that, I would have taken the question and multiplied everything by x squared plus 2x minus 1. So it becomes this. Multiplied that out, wrote it out, don't forget the plus cx plus d, and then just did the equating thing. And it was a little bit more fiddly, but you get the right answers. A is 4, B is minus 13, C is 33, D is minus 27. Which is best? don't know, I think in that question, I'm fairly sure the division method was probably quicker. And, you know, multiplying out that bracket, it's a bit fiddly. With this one, the previous one, well, it's a fairly simple bracket to multiply out. You be the judge. You don't really need to be confident with both methods as long as you've got a method that works. Right, we'll leave that there. Here's 3 questions for you to have a go at on page 20. So you've got a partial fractions with a repeated root. And then you've got one of these problems we're doing today where it's set out in this form, and then one where it's set out in the division form. But as I've said, you can use either method for either. If you can do those 3 questions, thumbs up, well done. I'll show you a solution to all 3 on Wednesday when I do my next video. But that's the real sort of acid test. And then we'll just do a little bit more of this on, sorry, school bell, I'm in school. We'll do a little bit more of this on Wednesday. I think then I'm going to give you one lesson of partial fractions practice. Forgive me, but it's just one of those things that comes up every year. And in the 2 videos we covered it. I'm not sure we did as much practice as I would have chosen, so we might do that, and then Friday we will move on to something new. So that's the way the week's going to sort of pan out, and yeah, I hope we get to see each other for one more week this term next week. But there you go, have a go at those 3 and keep in touch with any problems.